Hi, the doctor is in. I'm Dr. LB, and I am here to help you through your mathematical difficulties. Let's get started. Today, we explore the topic, what is a function? And in order to do that, let's first of all talk about a relation. A relation is any set of ordered pairs. The domain is the set of all first components in an ordered pair, or the x values, and the range is the set of all second components in the ordered pair, which represents the y values. A function is a correspondence from the first set to the second set, where each element in the domain corresponds to exactly one element in the range. So that's very important. Each element in the domain corresponds to exactly one element in the range. Let's look at some examples. So, do the following relations define functions? And what is the domain and the range? Well, we have a set of ordered pairs where 4 goes to 5, 6 goes to 7, and 8 goes to 8. So yes, we have x values going to exactly one y value. So we can say yes, this represents a function. So to find the set or the domain, we open our set notation and we simply list the x coordinates. For the range, we put the y coordinates in set notation. Let's look at another one. Here we have a set of ordered pairs where 5 goes to 6 and 5 goes to 7, 6 goes to 6, and 6 goes to 7. Now, does this represent a function? The answer to that, no, it does not, because you have the same x element going to two different y values. Remember that the x values have to go to exactly one y component. So this is not a function. 5 goes to 6 and 5 goes to 7, and we can't have that going on. The domain of this relation contains values 5 and 6. The range contains values 6 and 7. Let's look at another one. We have 4 going to 2, 5 going to 2, and 6 going to 2. Does this define a function? Well, yes, it does. Now, we can have different x elements going to the same y. You cannot have the same x going to two different y's. So here our domain contains 4, 5, and 6, and our range contains one element, and that's 2. So now we want to look at equations, and we want to determine if these equations define y as a function of x. So our first equation, we have x plus y equals 16. Now what we want to do is to get y on one side by itself. So we have y is 16 minus x. And then we need to determine, for each x I put into this equation, do I get exactly one y value back? Well, if I put x equals 1 here, I get y is 15. So yes, I get exactly one y value back, and that is a function. Our next equation, we have 3x equals y squared. So if I use the square root property to solve for y, I have y equals plus or minus the square root of 3x. Now, if I put x equals 1 into this equation, I'll get back two y values, a positive square root of 3 and a negative square root of 3. So I can say no, this is not a function. And if I look at x plus y cubed equals 64, I have y cubed equals 64 minus x, or y is the cube root of 64 minus x. Now, we don't need the plus or minus here because we have an index that is odd. So if I put in here, let's say 1, I'll have the cube root of 63. And that's just one value. So I can say, yes, this represents a function. We can also use the vertical line test to determine whether a graph represents a function. If I have a graph and if I draw a series of vertical lines, and if at least one vertical line touches the graph in more than one spot, I can say no, this is not a function. If I have another graph and I draw these vertical lines and each vertical line touches it in only one spot, I can say yes, this is a function. So remember that Dr. LB is always in. Please come back for more help.